Hello and good day to you. So today I'm doing a video on neuroevolution. This is my first experiment with neuroevolution, and kind of on balance I'd probably go down the line of saying it might have been a failure. The reason I say this is my original stock trading neural network was something that was a continuous reinforcement learning process where it has a policy and it goes and updates that policy, having tested it against the data, i.e. the way it learns is to try and updates its neurons, which represents the policy and the logic of the policy, having tried and failed. So for this time I did a neural evolution version, but I sort of switched gears into, rather than that try and fail pattern, it was trying to predict whether tomorrow would be a high, as in like a new high, like a breakout, to use stock trading parlance, or whether tomorrow would be a new low, where it would go, whether it would go past resistance or past support, to explain it in the way stock traders talk about it. In one sense, it didn't work because it doesn't make a huge amount of money when you run it. But the interesting thing is it works in the sense of it does appear that with enough volume data and enough neurons and enough bits of information, you can roughly work out whether tomorrow looks like a bad day or a good day. So this is its output. Now, if I click on the right thing, you can see it's got very small amounts of profit and loss. That's because it is actually stopping itself, very quickly or very shortly whenever there's going to be an increase or a decrease. So that's the bit where it's a failure. It's not going to make me a millionaire, but had to try it because, you sort of build this on the basis of, you're sort of looking at policy and trying to create a policy, but you do always wonder, is there a magic formula within the data? And I guess this is my attempt at working out whether there is a magic formula in the data, and probably there isn't, but there might be. But for like knowing the next day, roughly whether it be okay, more chance of being better or worse. So take that under advisement. Can't make money from it, but interesting thought anyway. So this is a representation of the artificial genome for the neural network, and what the artificial genome represents is the ways of which that neural network can be implemented, the data that it will receive as inputs. You can sort of see these inputs, open, close, volume, high are the number of data going backwards it should receive. And it's got a true-false matrix that tells it what data it should add into its inputs. Things like how many days since it had a high, or a new high within the data, and also the shape of the neural network, how many layers and the size of those layers, completely randomly generated and moved through. And like a normal genetic algorithm, it will implement the test. The AI that does the best, it will keep it. The AI that does the best will have more chance of the future AIs that it develops in the next generation copying data from it. And you can think of it, a gene, as it's number 81's a gene, 58's a gene, the true's a gene. But also, I made a decision, you might disagree with this, the general structure was a gene for me. So Whether it's 10, you can see that the one above is a smaller number of layers. If it's 10 layers or 8 layers, I've chosen a 50-50 chance whether it takes down either. Now, if you know much about neural networks, you'll know the next step is to do a look at a mutation. So you can sort of see, this is the code I wrote, and standard 50-50 whether it takes from mum or dad. And the way I implement a genetic algorithm is you don't get extermination, so you don't get the best best performing neural networks replace everything else. You get a new version of every previous AI with some recombinations from the better AI to try out. And it might be that I need to run this for longer. So when I say this hasn't worked, take this with a grain of salt that I'm going to run this over the next week. Now, I say the next week because I've got not a data science laptop. I don't have multiple cores. A solution to this would either be having lots of CPUs, a really powerful GPU, or just sort of running it in the background and leaving it and coming back. So I've just been running it, and that what you saw previously where it's got to 8 is quite a few hours, like a couple of days. I haven't run it. I've left it off overnight. So when I say a couple of days, it's probably a day or 24 hours in total, thereabouts. And if you look at these types of algorithms, now this is not comparable to the NEAT algorithm, which stands for Neuroevolution or Augmented Topology, which is the sort of stuff which is for the self-driving cars and the like. This is just trying to evolve the best answer to the hyperparameters for the neural network algorithm that I'm working with. So it's not going to, I don't think it's going to start playing arcade games or anything the like, which, strangely enough, the NEAT and the hyper-NEAT and its various descendants can actually do. So well worth looking into, and something I really want to learn, but I do think I think you have to do an implementation of it in C++, which is much faster than Python, but I'm getting a bit off topic. So anyway, this is I have a class for the neural network which contains all the data for the neural network, and I have a class for neural evolution, and the neural evolution tracks a database of different ways of implementing the neural network, and it's only ever showing on the previous page where it writes the console the best performing. So what it will do is it will cycle down through each of the different packets of data, because I've put them into a list to keep them separate, and choose randomly from mum or dad, and then I don't know whether 1% is the most accurate, but it will cycle through the genes that it's chosen from mum and dad and have a 1% chance of tweaking them randomly. Also, where it is possible for a gene to be forgotten, as in like it's possible for it to forget a layer within the neural network, I've also assigned it a 1%, because if you look at how living animals work, it's sort of deletion, changing or mutation of the gene into something else, or addition of a completely new random element. So the way I've sort of thought about it in my head is to implement those 3 parts within each level of the genetic algorithm that's building these neural networks and testing them. But this is why I love neuroevolution and why I'm interested in it, because when you sort of think of it in this way, it is almost sort of taking the data scientists out of the equation. Not entirely, not completely, but you could do a thing where you set the experiment up and walk away and leave it running on a CPU that you've got spare in the company, and come back and see what it does. And even if it doesn't work, this is why this genetic algorithm combination with neural network is interesting. Hopefully, by looking at what worked and what didn't, you might have some indicators of how to improve stuff. The very minimum, it's a very lazy way to do data science, and that's often good. As it saves somebody from sitting at a computer and trying to try all these different variants and failing. Just gets the computer to cycle through the different possible combinations and doing the fail success itself. Now, I probably will be running this for much longer. If I have a major success story, I might come back to you. But I do feel, with all my playing around with Q-learning and Neuroevolution, that it was the initial reinforcement learning policy creating neural network that ran the best. And I haven't found a way to get a neural network to optimize the best policy that could ever possibly exist, which is where I was trying to look for with this. So I'll go away, spend some time on it. I think I might be moving on to other forms of neural networks to do some exercises and learn some more, to then come back to this to see if I can do it better. But that's where I'm at with the stock trading AI. So many thanks. Have a good day. Bye.